Welcome all in class 7 on PCB design course. The entire PCB manufacturing process is very complicated and is affected by a variety of factors. There may be hundreds of components and thousands of solder connections on a single PCB board. Without testing and without adequate verification, the entire PCB manufacturing process is a hit and miss affair. The electronics manufacturing industries and product developers meet the challenge by establishing various inspection and testing procedures to ensure the quality of PCB. So in this class, we will discuss about some of the common inspection methods of PCB in order to maintain the quality of PCB. Some of the major inspection methods for PCB includes visual inspection, in-circuit testing, flying probe testing, automated optical inspection method, automated X-ray inspection method, burn-in testing, and functional testing. So in the series, the very first is about the visual inspection. So as the name suggests, visual inspection uses a magnifier or technician's bare eye to manually find solder defects and other visible defects such as component orientation, missing components, and board strains. This is the simplest and most basic inspection method for PCB. The advantage of visual method of inspection of PCB includes that it is cheap and easy to set up. Second, most major solder defects can be identified by this method. The disadvantage of this method includes that first, it is subject to human error and is time consuming. Second, it can only inspect visible solder joints. The hidden joints and underside joints cannot be evaluated by this method because these hidden or underside joints are not visible to technician. So in order to improve the inspection, we can use in-circuit testing method. So printed circuit board ICT is currently the most robust and popular type of PCB testing method. In this method, PCB to be tested is laid on bed of nails in circuit test equipment. That is, a bed of nails is there in the circuit test equipments. There may be a large number of bed of nails in the circuit test equipment depending upon the board that we are using. The electrical probes in a bed of nails can access the circuit nodes on the board. By sending current through these electrical probes at designated test points on board, the performance of various components present on board can be measured regardless of the other components connected to them, because bed of nails can be used to connect a single component, and at a single instant we can connect various components by using bed of nails. The advantage of this method includes first that it is fault coverage can be as high as 98%. That is, it can detect most of the faults in PCB. Second, efficient and quick method of testing mass product. So the disadvantage of this method includes that test jig is an additional expense. It is not suitable for small batch production or prototyping, as any change to the design requires the test jig to be modified or remade. It cannot access certain defects, for example, excess or insufficient solder or solder voids. So the third method to inspect the PCB is flying probe. In flying probe is a form of in-circuit testing which uses flying probes to access the PCB test points. The number of probes in flying probe method are less as compared to in-circuit testing method. The flying probes are electromechanically controlled to access components on printed circuit assemblies. The flying probe or flying needle testing can be programmed to check the value of passive parts, directly check diode transistor orientation, and perform voltage measurements. The advantage of this method includes that it is cheaper and faster to implement or to modify. No fixture is required for this type of testing. The disadvantage of this technique includes that here testing is too slow for mass testing. Second, it cannot access certain defects, for example, excess or insufficient solders or voids, etc. So, in order to overcome the shortcomings of these methods, we can use automated optical inspection method. Automated optical inspection method uses cameras to take high resolution images of PCB to be tested and then compare this image of PCB with a template design of board or with a database of images of good and bad boards. For AOI, the advantage includes high flexibility and extremely short test programming time. The advantage of this method include that most major solder defects can be identified by this method. Second, it is more consistent and accurate than manual visual inspection. Third, it can be added to the production line directly for early detection of defects. The disadvantage of AOI includes that AOI is passive testing method. That is, it can only detect surface defects. It cannot tell about the performance of components, some shorts or some opens which are available on PCB. The next in series is automated X-ray inspection method. So automated X-ray inspection shares the same principle as that with AOI, that is, inspection is carried out through capturing the images. The difference between them lies in the source. Automated optical inspection method depends on light source to capture the images, while automated X-ray inspection method uses X-rays to capture the image. The X-ray images of PCBs, the metal is dark, while other metals like glass, plastic, and ceramics are transparent. This makes it easy to see metallic components. One of the images of PCB using X-rays is as shown in the slide. Here, traces as well as metallic part of components are represented by dark. So, any loose of connection, any insufficient solder can be inspected from this diagram. The X-ray technician is able to locate defects in solder connections, internal traces, and barrels very precisely. Next in series is burn-in testing. So during burn-in testing, boards are subjected to conditions exceeding the rated operating conditions to detect early failures. The operating condition tested can include temperature, voltage, current, operating frequency, or any other operating condition relevant to the design. The advantage of burn-in testing includes that it checks the performance in real environmental conditions that other testing methods cannot perform. The disadvantage of this method includes that the testing process may shorten the product's lifespan. The last in the series is functional testing. The functional testing is performed in the last phase of production to serve as the final quality control procedure. In short, it ensures that the device under test operates as intended. Depending on the complexity of the design and specific testing requirements, the functional testing can be as simple as on-off power test to comprehensive test with strict protocols and testing softwares. So these were some of the common methods for inspection of PCB, and we want to discuss these common methods. So this was all in this class. Thank you.